All right, so today we're going to talk a bit about typecasting. We'll talk about rounding probably in another video, just because it might just be too long. All right, the type of result is determined by the types of the operands, not their values. So, for example, we discussed this briefly at some point. If you do 13 divided by 2, 13 is an integer, 2 is an integer, so the result is just an integer. We would want it to be 6.5 in our normal world, but this is not normal world, this is Java. So 3 divided by 2 is just 6 in Java. It literally just ignores the decimal or remainder completely. Okay. If you wanted the answer to be 6.5, you have to do what's called typecasting. So you have to make it so that one of them is a double. So if I do 13 divided by 2.0, so 2.0 is now a double. This is a double, and it takes more memory to store 2.0 than it does 13. Even though 13 is the bigger number, 2.0 takes more memory because it's a double. So it assumes that you want your answer to be a double. So there's when we would get that 6.5. Okay, so 2.0 is a double. 13 is an integer, so it takes the larger value. So the larger amount of memory it would take. So that's why it's 6.5. Interesting, right? So intermediate results, so it doesn't really matter. So if somewhere in your program, in your calculation, you had 13 divided by 2, you would lose that 0.5 somewhere if you don't put a 0.0 on the 13 or the 2. Okay, we're talking about primitive types here. Obviously, you can't put 0.0 on, a word. So we will be discussing how we typecast objects and things like that later. All right, so for example, if you have a math constants or literal values here, we have 3 divided by 4. So if we're storing that in a double, even though we're storing it in a double, 3 divided by 4, the math is done here. So first the calculation is done. So you have to realize this doesn't all happen at once. The calculation is done first. The calculation is done first, and then the assignment. So the assignment is when we actually put the value into result. So first what it does is it figures out, so this is what's happening. It figures out that 3 divided by 4, it does the math. It doesn't really care what result is. So 3 divided by 4 is 0. And then when it sees that result is a double, it's like, oh, okay. There we go. So it makes it a double. But it does not remember that it did 3 divided by 4 and that it should be 0.75. So the way that you have to make, when you're doing the calculations, one of the pieces has to be a double if you want your answer to be a double. At least one. They both could be. That's not the point. So 3.0 divided by 4, that result is going to be 0.75. Okay, so how do you do this with variables? So if you want to do something like this with variables, you can't just put a 0.0, like you can't do x.0. And x is an integer, and it's using integer memory to store it. So if I let's just make everything doubles at this point, it would just increase the size of your, program exponentially. And if you have hundreds and thousands of variables, it's going to be a problem. So we can't just make that a double just because we want the result to be a double. So what we can do, so as we can see here, x divided by y, it does the calculation 3 divided by 4, it gets 0, and it stores 0.0 in there. So what can I do? I can, instead, without increasing the memory that it takes to store the x, I can do what's called typecasting. And typecasting just means I'm going to change x's type for a minute, for this moment in time, for just this calculation. I am in essence going to make x 3.0 and then divide it by y. So it would be 3.0 divided by 4, which is what I want, and that would allow me to store 7.5 or 0.75 in result. So that's the idea. It doesn't increase the memory because result is still a double. So that value was going to be a double regardless. So now it just makes it so our answer is the way we want it. Okay. So something you do have to be careful of with the situation is when you are typecasting, you have to make sure you typecast the variable that you want, not the calculation. So if you look at something here, parentheses must be done first. So x divided by y is going to be done first. So if x is still 3 and y is still 4, you're still going to get 0 in this spot. Then it's going to be typecasted. So this is going to be 0.0 again. So it doesn't help our situation. So when you typecast, the typecast has to be smack up against the x. So typecasting comes before division, but after multiplication. So this is the way it should look. Notice that the parentheses, if we were going to put parentheses around the calculations, it would be around that. So this part is going to be done first. So for order of operations here, parentheses do happen first. We have these situations, which we'll talk about if we haven't yet. Multiplication and division. So you do parentheses, what's in parentheses first. So typecasting falls right before that. Okay, and then you have addition and subtraction and all that good stuff. So parentheses, then typecasting. So you got to be careful when you're doing the situation that when you're doing the parentheses, you put them around the correct thing. So with typecasting, you have to put parentheses around the type. So in this case, the type that we've been using is double, right next to the variable you want to change. Okay, and then the division can happen. Okay, we're going to use this situation when we're writing formulas. So a formula like this, converting Fahrenheit to Celsius, where C is C is a double, and F has been declared somewhere else, and it has a value in it. You just got to be careful when you're writing formulas. It's not a calculator. You do have to do a little bit more finagling when you're doing it. So if you were to write this in your calculator, you would write 5 divided by 9, and then a parenthesis, and then F minus 32 with the value for F in there, or if it was you were graphing it or whatever. So this situation will cause a couple of errors. This guy wouldn't even compile at this point. First thing you have to remember is that parentheses do not mean multiplication in Java. So parentheses, not multiplication. You have to put the times sign in. So 5 divided by 9 times F minus 32, and that would be fine. So it would do the F minus 32 first, and then the 5 divided by 9 times whatever the answer is. The problem with this is, though, the 5 divided by 9 here, that is 0. 5 is an integer, 9 is an integer. So this kind of situation might get lost when you're writing formulas, especially if you have variables more than just the one variable. So just be careful when you're doing this, that you do typecast for a moment at that time, so you can make that 5.0 divided by 9. Especially if it's a repeating decimal, you don't want to mess with that. You don't want to the rounding errors and things like that. So you should make sure that you use 5.0 divided by 9 or 5 divided by 9.0, which will give you a non-zero answer here. So then this is not needed. All right, so that is a little bit about typecasting. We'll start using it in programs and things like that, and we'll talk about rounding later. Have a nice day.